Hello, this is meant to be for my Advanced Calculus class 450, and we're using the textbook Patrick Fitzpatrick, the second edition. And I just want to do a problem, um, the problem from the textbook that says that if n is a monotone sequence, prove that an converges if and only if n squared converges. And then it also says to check that this doesn't work if the monotonicity assumption is not there. So let's suppose n is a monotone. Okay, let me do the only if side first. Okay. For this, I will assume n converges, and then I will show that n squared converges. And actually, for this one, I don't even need the assumption of monotonicity. So let's suppose that an converges to a number a. Well, so n squared being n times n converge to, by the product rule, n a times a. It converges to a times a, which equals a squared. So n squared is convergent, and that's it. Okay? To show the if side, let's suppose that an squared converges. So it is bounded. Because every convergent sequence is bounded. Let's say by m. So then there exists an m such that an squared is less or equal to m for each n. That means that for each n, an squared is less or equal to m, which really implies that an is less or equal to the square root of m. Because m is positive and absolute value of n is positive, the squares are an squared is less or equal to m does imply that an is less or equal to m. That means that the sequence an now is bounded. Well, okay, so we had a monotone sequence to begin with, and we showed that it is bounded, and therefore it is convergent. That's because every monotone bounded sequence is convergent. Okay, so that's pretty much what the problem is asking us to do. The next thing to do is to show that without the monotonicity assumption, this statement doesn't work. Well, if you take the sequence -1 to the power of n, this is the sequence that is not convergent. This is not convergent. However, if you take the squares of those terms, which are -1s and 1s, this is the sequence of 1s, which converge to 1. So the an squared now converges, but an does not converge. So this implication fails without the assumption of monotonicity. All right, well, thank you so much. I hope you check this out and you continue to do your work. Goodbye.